In this video, we are going to look at this example. Two bodies, A and B, with masses 20 kilograms and 40 kilograms respectively, collide with each other. Before collision, body A is moving to the right with a speed of 15.0 meter per second, and body B is moving towards body A with a speed of 5.0 meter per second. After the collision, body A is moving with a speed of 8.0 meter per second to the left. Part A, find the speed of body B after the collision. Part B, calculate the loss in kinetic energy of the system. Given that the collision lasted for 0.25 seconds, find the average force exchanged between the two bodies. The setup is like this. We have the two bodies before collision. Body A, which is 20 kilograms, is moving with velocity 15.0 meter per second to the right, and body B, which is 40 kilograms, is moving with velocity 5.0 meter per second to the left. Then, after the collision, body A moves with velocity 8.0 meter per second to the left. Now we need to obtain the speed of body B. Now remember that speed is just the magnitude of the velocity. Now to get the velocity of body B, we simply apply the conservation of momentum, which is written as MAUA plus MBUB equals to MAVA plus MBVB. When applying this equation, we need to have a sign convention in place in order to get the directions correct. So I am placing the right as the positive direction. Hence we can write UA equals to plus 15.0 meter per second and UB equals to minus 5.0 meter per second. The plus for UA is because body A is moving to the right and we have taken the right as the positive direction. The minus means that the initial velocity of body B is directed opposite to our chosen positive direction, which is to the right. Therefore, it means that the velocity of object B before collision is towards the left. Then, for the final velocities, we have VA equals to minus 8.0 meter per second, and VB we don't know, and this is exactly what we have to find. The masses are simply MA equals to 20 kilograms and MB equals to 40 kilograms. So we substitute the values we have, and we should obtain VB equals to plus 6.5 meter per second. Since we obtain it as positive, it means the direction of motion of body B is to the right, as we have chosen the right as the positive direction. Now for part B, to find the loss in total kinetic energy, or the kinetic energy of the system, when we say system here, we mean the system of body A and body B. So to find the loss in the kinetic energy of the system, we have to calculate the total kinetic energy of A and B before collision and the total kinetic energy of A and B after collision. So we start with the total kinetic energy before collision, which is written as half MA UA squared plus half MB UB squared. If we substitute the values, we should get the total kinetic energy of A and B before collision as 2750 joule. Then we have to calculate the total kinetic energy of A and B after collision. The sum of kinetic energies after collision equals to half MA VA squared plus half MB VB squared. And if we substitute the values, we should get 1485 joule. Then the loss in kinetic energy of the system is simply the loss in the total kinetic energy of A and B due to the collision. So the sum of the kinetic energies lost in the collision is simply equals to the total kinetic energy of A and B before collision and subtract the total kinetic energies of A and B after collision. And if we do this, we'll have 2750 joule minus 1485 joule, which should give you 1265 joule, which is, to two significant figures, 1300 joule. Now for part C, to calculate the force exchange, we just need to calculate the force on only one of the bodies. Now why is that? It is because from Newton's third law, the force exerted by body A on body B is equal but opposite in direction to the force exerted by body B on body A. So we simply have to choose one of the bodies. So let's choose body A. The force experienced by body A is FRA equals to delta PA over delta T, which is equals to MA times, in bracket, VA minus UA divided by delta T. And remember that this equation has to be applied in line with the sign convention that we have chosen, where we have chosen the right as the positive direction. So if we substitute, we have FRA equals to 20 times, in bracket, minus 8.0 minus 15.0 divided by 0.25, and this is in Newton, and we should get minus 1840 Newton. Now, since this force is negative, it simply means it is to the left. Therefore, body A experienced a force of 1840 Newton to the left due to the collision with body B. Then, from Newton's third law, we have FRB equals to minus FRA, which then is simply going to be equals to minus 1840 Newton, which gives you FRB as plus 1840 Newton, which means the force experienced by body B from body A points to the right.